guys, I am Sanjay. I am here to tell you about some basics of Spring MVC, but before going on to the topic, I would like to take you to my course way forward. So we'll covering some introduction, the overview of JSP and Servlet, MVC Basics, and we'll move on to DI and IOC, that is inversion control and dependency injection. So what is Spring? And why is this Spring getting so much popularity, or why should we use Spring? I will answer those questions, but before going inside, I would like to show you how a typical client-server application works. So if we talk about client-server application, I'll move to servlets and JSPs. So in a typical client-server application, the user requests for a resource, that is with the help of the URL. The servlet processes that request and sends a response back to the user. The same is in case of JSP. So what happens here is we have some Java code inside HTML and some HTML with Java, which makes our life a bit tough. So to remove this toughness of non-cleanability, we have Spring. Spring MVC works on a normal MVC pattern. I will talk more about Spring and Spring MVC. You'll use these words and you'll listen these words more frequent. Okay. So Spring MVC, the MVC architecture pattern requires and I will talk about what is MVC. So in terms of Spring MVC, the MVC architecture pattern requires the separation of user interface, that is user interface in our case is view, the data being processed, that is the model, and the controller which manages the interaction between the view and the model. Now if we talk about what is a Spring, I would like to say you can think it as a framework or a platform to manage business logics or relationship between them independently without any problem. What good in Spring I find is we need not depend on any other class or interface, unlike other frameworks such as the servlets and JSPs. We have tough names, J2E, components, EJB, servlets, etc. So we'll think about a typical servlet. How a typical servlet looks like. A typical servlet would look like this. So my servlet extending from HTTP servlet. Okay. Now think of just a small functionality if I need to do. What we'll do is we'll bounce the server back, we'll test our code, so this consumes a lot of time. So what Spring gives us the flexibility of testing our code in a testing environment. We need not to bounce our application, we can test the code whatever way we want. So Spring Designers is designed to keep the framework simple and lightweight. So we'll see more of this in the coming sessions. One important point I would like to highlight is Spring is becoming popular because of its inversion control feature, and another one is dependency injection. Well, programmers are often confused about inversion control and dependency injection. So to clarify that, I would say I would rather use these words interchangeably. IOC or inversion of control is more a general concept, and dependency injection or DI is a concrete design pattern. So we'll use IOC for inversion of control and DI for dependency injection. In Spring, how this IOC is implemented, it's implemented by using a bean factory. We'll see some bean factories or beans configurations in XMLs. You'll see in the coming lectures. But don't worry about these big names, just feed it. You have something named as bean factory, you have something named as application context, and feed it inside your head right now. So what a bin factory does it manages the complete life cycle of Java beans, whatever we declare. To make IOC more clear, I would get out of the fever of using technical names and tell you a simple story. Suppose you are having a home in a hill area having lots of snowfalls, and in that day you are inside a blanket in your home, and suddenly your boss calls you and asks to write him email, and the constraint is that you don't have your office system or laptop, and you have your desktop in your home. So now when you're using your desktop computer, you are fully slaved, or say you are controlled. You have to sit before the screen, get out of blanket before that, yeah, and look at it, using a keyboard to type and a mouse to navigate. So my friend, trust me, a bad written code can slave you even more than that. I will talk about how we can control it. Now if you replace your desktop with a laptop, then you have somewhat inverted the control. You could easily take it and move around. So now you can control where you are with your computer instead of computer controlling you. This is what inversion control says. It's about getting a freedom, flexibility, less dependency. One more situation I can imagine is your boss controlling you in your office, and in the upcoming days in your career you become a boss and you control someone else. So the situation is changed and you're invertibly controlling. So we'll now move to DI, that is Dependency Injection. Yeah. What it means in practice is the method doesn't have a direct dependency on a particular implementation. Any implementation that meets the requirements can be passed as a parameter. Don't go into the words, just leave this. I will tell you in a more simple way by giving you an example. Suppose you create an employee object. With that you have an address object as well. So what we'll do is we'll create the address object inside the EMPB or employee object, whatever you think of it. So if address is defined as a dependency by the employee object in case of Spring, so there is no explicitly creation of object. So here no object is created of myself. This is done by framework. That is what dependency injection is all about. How sweet. That's why I love Spring, you know. So to explain it more, I'll take an example of, normally we'll take an example of employee service. We'll write it like this: public class EMPL service. My keyboard is a bit, you know, lazy. Implements EMPL service. Let's assume EMPL service is already written. Okay. So we have for that we have a DAO, data access object. So we'll write it as EMPL DAO, suppose, and we'll new DAO. So that's what we write generally, right? Yeah. And we have overridden code of suppose a method is there, name as Ioc. Yeah. Public boolean add, correct? So this looks like this, and we'll return EMPL DAO dot add. Now let's pass some parameters so that it looks good. Suppose simple DAO class, simple DAO class, the name should be same, right? So this much we can do. So this looks perfect, right? It's not, my dear friend. Think for a second, what is the problem with this piece of code? The problem is, suppose your app is up and fully running, and what you need to do is you have to create a local copy of EMPL DAO every time. And my dear friend, this is a very expensive operation because it has some database connectivity code, a database side of code. So it's expensive code. It doesn't make sense for me to create a separate instances of same DAO. Instead of, we can create a single instance and share among multiple instances of EMPL service. Sorry, here I missed it. IMPL should be implementation class, right? So it doesn't make sense for me to create a separate instances of same EMPL DO. So what we can do in this case is we can create a one instance and share among multiple instances of EMPL service, right? So in terms of code, in terms of coupling, this code is said to be highly coupled, and where it is coupled, it's coupled around EMPL DO by creating instances of DO using the new keyword. We'll write new DO, this one, right? So this code is said to be highly coupled. So dependency injection, now we'll forget about dependency injection for right now. So now we are making our code a bit cheaper using the dependency injection. Yeah, now you can think of dependency injection. Okay, so what we'll do here is we just remove it. I'll just remove this piece of code, and what Spring will do is Spring will take care of creation of object of EMPL DO. So in this case, it's now possible to I can share a single object that was in my case a costly object of doing a new into multiple EMPL service classes. Since EMPL service class is not creating an instance of DO by itself, so it's said to be loosely coupled in my case, and this EMPL DO is injected in runtime by the framework. So what you can think of it now is we can create and concrete a demo or a dummy class of EMPL DO and test our code easily on any production environment. Sorry, right? Yeah. So this was our dependency injection. So isn't it? It's quite a good feature that Spring has given to us. So the EMPL DO is dependency of EMPL service and is injected with a framework rather than we creating object, right? Cool. This is what Spring DI says to us. So the Spring MVC or the Spring framework is built upon inversion of control principle, and dependency injection, what it is the technique to implement the IOC inside our applications. Okay, so to be more specific, IOC is a kind of mechanism to achieve the loose coupling between the object dependency. Okay, to achieve the loose coupling of the objects in runtime, the objects define their dependencies that are injected by other objects. The Spring Ioc Container. Now we will speak more about Spring Ioc Container. Spring Ioc Container is a program that injects dependencies into an object and makes it easy for use. So Spring Ioc is the core of the Spring framework. Then the inversion of control manages the Java objects from their creation until destruction and makes them loosely coupled. So we'll talk a bit more about the packages, the classes, the interfaces, the bean factory, the application context, configurations, etc. So we'll be covering a bit more technical now. So we have two basic packages that contains the functionality of Spring Ioc: the bean factory, org.spring framework beans and org.spring framework.context. These are the two packages that contains the basic functionality of Spring Ioc. The bean factory interface provides we'll say a high level configuration or some mechanism to manage the type of objects. Okay, it contains the basic functionality for the Ioc implementation. That's it. Now if we talk about application context, it's a serve interface and this is built on Bean Factory. It provides an application level context to be used in Spring Web Apps. It's a set of Bean Factory, or you can say, and any functionality to provided by Bean Factory is also available in application context. So we'll talk more about it. We'll talk about the differences right away instead of defining and what it is. So a number of people seems to be confused in between these two interfaces. So Bean Factory interface is the core of IOC. Simple as this. It's just instantaneous and configures the beans, whereas the application context on the other end is built on Bean Factory, as I said. So it does everything as Bean Factory does and some extra functionalities. So application context is a choice that we use in most of the situation. How we configure the beans in Spring IOC? So Spring IOC container assumes some sort of configurations, mostly in terms of XML format. So these are done in XMLs. All the bean declarations are done in XMLs. So we have some configurations, we have some IOC based annotation based configuration, we have some XML based configuration, we have Java based configurations. We'll talk more about this. We have @ that is the annotation. Okay, cool. So I would just like to show you how a simple XML definition would look like. I'll open one of my application. We'll see. Yeah. So yeah, I have it. Yeah, this one. A simple declaration of beans. It always starts with the bean tag, ends with the beans. Yeah, here we'll see, and inside that we have lots of bean configurations defined. This will define the bean. We have ID, we can give an ID here as well, class, parameters, etc. Now we'll use the Ioc container to manage the dependency. So we have two kinds of dependencies: the setter injection, the constructor injection. We do basically, will not see here, but we'll implement in the coming sessions. So this all about DI and Spring IOC. So we'll a bit look in the Spring Mvc web flow. So have a Spring Mvc Flows. I will go to our basic diagram. I will use this diagram frequently, so just have a look at it. At the core of the Spring Mvc is a servlet, that is the dispatcher servlet or the front controller that handles every request. Now what this front controller does, it routes the HTTP request that the user sends to a controller class authored by the developers, that is written over there. The controller class, what it does, it handles the request and decides which view should be sent to the front controller or the dispatcher servlet. Now these are all set up done by the web.xml. We have the web.xml. All the requests that comes in will go to the dispatcher servlet, and the dispatcher servlet will ultimately forward the control to the controller. I will show you a snapshot of web.xml that we use here. Yeah, see here we are describing our URL pattern, the servlet name corresponding, and the servlet class that is defined, and the servlet class is dispatcher servlet. Now as soon as the request comes in, it handles to dispatcher servlet. And what does dispatcher servlet does? The dispatcher servlet forwards the request to a controller. We have the controller mappings right in the beans. So it in a high level you can assume it like that: web.xml to servlet, web.xml to dispatcher servlet, dispatcher servlet to the controller, and controller returns a message or a view name to the front controller. So a front controller now has the view name. So now the front controller is confused about the view name. So how will it resolve its confusion? It will go to a class named viewResolver class. Okay, so it will help him to resolve his confusion and render the response back to the front controller, and front controller will take the response back to the user. So I will go a bit more depth. So Spring uses the handler mappings. So suppose a request comes into the controller. The controller, there are some handler mappings associated with these controllers. We'll see a bit more about it inside a configuration. We'll talk about a configuration. Suppose here I have written like this. In place of ID, we'll give a name equals to that dot backslash sa.htm or simply sa. So as soon as a request comes with this URL, it will go for this class. Don't go to the name, I'm just showing it. So in this way you'll write the bean configurations. Okay, we'll have some handler mapping declaration inside it. So the heavy lifting in this web application is done by the controller class. This is an ordinary Java class that extends from abstract controller, and we'll use some annotation in case we're using annotation based configurations. So all this configuration will do it in this Python servlet.xml, what you are seeing here. That is my bean configuration. So now the method that controller returns the view name, and it returns to the front controller here. So we'll quickly cover it. So in the final description, I'm describing you finally how it works. User request for a front user request. This through the web.xml, it goes to the front controller. Front controller controls the request, forwards the request to the controller, and there are some handler mappings associated with the URLs, and all those processings are done here, and the controller sends the response back to the front controller with the help of the view name and the data associated with it. Now the front controller are confused about the view, where it will get the view name. So it goes to the view resolver. We'll see how a view resolver is described. The view resolver class is org.springframework.web.servlet.view.internal resource view resolver, where we declare the prefixes and suffixes. With the help of those prefixes and suffixes, it gets a view name, adds to that suffix, adds a suffix to that with the prefix, gets the exact location, and the view resolver forwards that view to the controller, and the front controller, and the front controller, what it does, it sends a response back to the user with the data. So this is all about Spring MVC workflow. I think you like my video. Please like it, share it, subscribe it, and thank you for watching it. We'll cover in the next session a demo application with the basic setup. Thank you.